On to 8.2a, using the intermediate value theorem to show that there exists an x in 0 to pi over 2 such that cosine of x equals x. Well, here we have the intermediate value theorem. We're gonna take this function and put it equal to 0. Just for example, we see that pi over 2 and 3 pi over 2 cosine are equal to 0. So let's let f of x equals cosine of x minus x. We're going to let f of x equals L, which equals 0. Okay? So f of 0, we get cosine of 0 is 1. And then minus 0, that's equal 1, which is greater than 0. Then we get f of pi over 2. We're using our bounds here, right? Pi over 2 of cosine is 0 minus pi over 2, which is negative pi over 2, which is less than 0. By the intermediate value theorem, we can use this and plug our values in. Check. If that checks out, we see that x is in 0 to pi over 2, where f of x equals 0, which equals L, which proves our point here. Now moving to 8.2b, we want to show how many values of x from 0 to 11 does tangent of x equals x. Well, we have tangent of 0 equals 0, which proves this here. But for all of these other problems, tangent is going to return pretty small decimals. We can see that those will never equal 1 through 11. So they're never going to equal x here. So we can only have x equals 0, where tangent x equals x. For C, we have to prove that f must have a fixed point. Well, if we take a function where we take our f of x, we're going to equal it to 0, which is going to be our function. So we have f of x minus x, where g, our function here, is contained in 0, 1. Well, if we have g of 0, we just get f of 0, which is greater than 0. If we have g of 1, we're going to get f of 1 minus 1, which will be less than 0. Now again, by the intermediate value theorem, we can see that there exists a c in 0, 1, where f of c equals L equals 0. Basically, we can see that we have the f of a less than L is less than f of b. This is kind of what we're getting here. Well, we proved that here, so we can say that f must have a fixed point such that f of x equals x. On to 8.3. We're going to prove that f of x equals the cube root of x has no derivative at c equals 0. So we're going to use the derivative, the definition of derivative, which is plugged in here. So we get the cube root of x minus 0 over x minus 0, right? Well, that gives us the limit of the cube root of x over x. Well, we see that the cube root of x can be positive or negative. It's not always going to be a positive number. Therefore, the limit does not exist. And we can conclude that g is not differentiable at c equals 0.